For section 15.5, again, we're not focusing so much on paths like we did at the start of the chapter, but instead we're going to look at relationships between vertices. This time we're going to look at something called graph coloring. Okay, so when we're looking at graph coloring, our goal is to create what's called a proper coloring. If you remember the map assignment from the beginning of our unit, that introductory set of problems you did, one of them was to color the map of the United States using as few colors as possible so that no states that share a border have the same color. What I was asking you there to do was to create a proper coloring of the map of the United States. So the idea behind a proper coloring is that I am assigning colors to vertices of a graph so that no adjacent vertices have the same color. That means if two vertices share an edge, they cannot be the same color. So this one could be purple and this one could not. On your map, that means that states that share a border could not be the same color. So for example, Illinois and Indiana share a border. They could not be the same color. Okay. Again, vertices are adjacent if they have a common edge. So these, again, could not be the same color. When I find that smallest number I could possibly use to color a graph so that I've created a proper coloring, I've found what's called the chromatic number. Now I could always create a proper coloring by just coloring every single vertex a different color. If I use a different color for every single vertex, by default, none of the adjacent vertices, I should say, are going to be the same because I used a different color for every single one. But that's not always an efficient or even possible way to take a look at a graph coloring. So usually what we're looking for is what's called the chromatic number. So that's the fewest colors possible that I can use to create a proper coloring. Again, adjacent vertices cannot be the same color. If I'm looking at a map, territories that share a border cannot be the same color. If they meet at just a corner, so if we think about a checkerboard, this region and this region could be the same color. That's okay. But if they share a border, for example, this region and this region, they could not be the same color. Turns out that you can actually color any map with a maximum of 4 colors. So that map of the US that I asked you to color, you should have been able to color it using 4 colors. You can't do it in 3. If you used 5, you could have recolored it in a different way so that you could have only used 4. So we're going to take a look at some examples of graph coloring, some problems in context, some applications of graph coloring, keeping in mind we always want to use the fewest colors possible and adjacent vertices cannot be the same color. So the first example we're going to look at, you guys actually have some exposure to. When we talk about schedules, that's actually a graph theory problem. So if you've ever created your schedule and then later on been called down to guidance because there was a conflict in your schedule and you needed to switch a class, that means that there was in our graph, in our big map of all the courses that are offered in our master schedule, there was an instance where you had maybe selected 2 classes that were both only offered during 4th hour. And so since they're both only offered during 4th hour, you have to pick one. So what we try to do is avoid situations like that. And we can use graph theory and these graph colorings to be able to do that. So what I'm going to do for this problem is actually create a graph out of this data. So we have 9 different classes that we're looking at, and I've given each class a little coded letter at the end, and then that's the coded letter that you see up at the top here. And then anytime I have somebody who wants to take both of those classes, I see an X in my grid. So this X here means that somebody wants to take Honors Physics 2, and that C stands for Calculus, and Calculus. So what I want to do is try and make sure I don't offer those classes only at the same time. So I wouldn't want to have my only section of Honors Physics 2 during my only section of Calculus. Same with, let's say, Discrete Math and PE. I want to make sure that the only time I'm offering those 2 courses for this particular grade level are not at the same time. So what we're going to do is take this whole big chart that we have here and turn it into a graph. So I'm going to make a vertex for every class. when I draw my vertices, I'm going to draw them as big open circles because we're going to color them. So I'm going to make a vertex and label it for every class. I'm just going to do a 3 by 3 little grid of vertices here, leaving some space in between, social distancing, leaving some space in between, and again, make sure you label your vertices. That will be important for later. So physics, calculus, discrete math, PE, there's our senior English, and German, and then I've got collegiate reading, band, and psychology. And now I'm going to draw an edge between any two vertices where I have a conflict, where I have an X in the table. So I have an X in the table between physics and calculus, so I'm going to draw an edge between physics and calculus. Now notice I have another X here that represents a conflict between physics and calculus, right? We did this one, but I've got the same thing here. I don't need to repeat that edge. We're going to see these conflicts repeated throughout our table because we have every class listed here and here. I only need one edge, so this one's already taken care of. Then I've got another edge to draw between physics and discrete. So physics and discrete. That one's done. And then here again, physics and discrete, I already have that edge, so that one's done. So our first block in our table is done. For our next chunk, we've got physics and PE. So I'm going to draw an edge between physics and PE. And then this is PE and discrete. So draw an edge between PE and discrete. And then here we have discrete and German. So I'm going to draw an edge between my vertex for discrete and my vertex for German. And I keep going. This is a conflict, somebody that wants to take both collegiate reading and physics. So I need an edge between physics and collegiate reading. And then this is discrete and collegiate reading. So I'm going to do an edge here. Then I've got band and discrete. So I'm going to do an edge here. And then I've got calculus and psychology. So calculus is my C, psychology is my S. So I'm going to go straight through here. That's that first column. Now I'm going to come up here and do the middle column. So this is PE and physics. I already have that edge. Then I've got PE and discrete. I already have that edge. And then German and discrete. I already have that edge. So we're good in that chunk. That one's already done. Now I've got PE and German. So I'm going to draw an edge between PE and German. Then I've got senior English and German. So English and German. Then I've got PE and German, we did that one, and senior English and German, we did that one as well. For my last block here, I've got collegiate reading and English, so reading and English. Then collegiate reading and German. Then I've got band and German. Band and German, we'll draw that one in. PE and psychology. So there's psychology and connect that to PE. Then I've got English and psychology. So connect those. And then psychology and German. Connect those. And then for our last column here, collegiate reading and physics. We've already got that. Collegiate reading and discrete math. We've already got that. Calculus and psychology, we've already got that. Band and discrete math, we've already got that. Collegiate reading and English, we already have. Collegiate reading and German, we already have. German and band, we have. Psychology and PE, we have. Psychology and English, we have. And psychology and German, we have. So this is our whole graph. for that table. Now what we're going to do is create a proper coloring for this graph. So you're going to need a few different either colored pencils or couple different colored pens or crayons or whatever you've got. If you only have one writing utensil with you, you can also color your graph by just labeling each vertex. Let's say this is my graph. Labeling each vertex with a number. So I could say this is color 1, this is color 2, and this is color 3. That will work as well. I'm going to use different colored pens and markers. Again, use what you have. If you don't have multicolored writing utensils, highlighters, whatever, then number 1, 2, 3 for your different colors. So as I'm coloring, I want to start with vertices of high degree. Okay, I'm starting with vertices of high degree because that will help me eliminate a lot of adjacent vertices right off the bat. Okay, so it looks like my high degree vertices are, PE's got 4, German's got 2, 4, 6, that's a lot. Psychology has 5, discrete's got 2, 4, 5. I think German is our highest degree vertex here. So I'm going to start by coloring German. I'm going to color it purple as my first color. Now I'm going to color anything else that I possibly can, keeping in mind I cannot color anything that is directly connected to German. So I can't color discrete or psychology or band or collegiate reading or English or PE. So I can color one of these two. I'm going to choose to color the higher degree vertex. So I'm going to choose to color physics. Once I color physics, now that's directly connected to calculus, I can no longer color that vertex. At this point, every vertex in the graph is connected to a purple vertex. And at least one purple vertex. Reading, for example, is connected to 2 purple vertices. Since everything's connected to a purple vertex, I have to change colors. So I'm going to switch to red. And now I'm going to start the same way. Nothing in this graph is connected to red yet, so I get to pick whatever I want. I'm going to start by coloring a vertex that has a high degree. So it looks like my high degree vertices right now are discrete and psychology. That's 4. PE has 4. Discrete I think is our highest right now with 5. So I'm going to color discrete with my second color. And then I'm going to color anything else that I possibly can. So I cannot color PE, collegiate reading. I cannot color band. German and physics are already colored. So I can color, right now, I can color English, calculus, or psychology. Okay. So I've got a choice to make here. I can color psychology. That's my high degree vertex of the options left. Or I can color both calculus and English. So this is where, again, you have a choice to make. Some of these choices may affect your coloring farther on into the problem. Right now, I'm going to choose to color both English and calculus. And then I'm going to switch to a new color because now everything in my graph is connected to a red vertex. Again, with my new color, I'm going to start with a high degree vertex if possible. So I'm going to go psychology here. It's got 4, so does PE. I can color one or the other, but not both, so I'm going to color psychology. And then I know I cannot color PE, but I could color band and reading. I can color both of these at this point. They're not connected to psychology and they're not connected to each other, so I get to color both of these vertices here. Okay. And then we've got one vertex left, so I have to switch colors. I'll make this my last color. That's blue for me. I don't know if you can tell. But that means that I had to use 4 colors here. Now, on a map, we know that you can color any map with at most 4 colors. That's not necessarily true of every graph that we'll create or see. On a map, 4 is the most. In this particular instance, for this particular graph, 4 was our most. So the problem that we were looking at here was which courses can be scheduled at the same time. The courses that can be scheduled at the same time are any courses that are the same color because they don't share any students. So as I'm looking at what I've created here with my graph, I've created a schedule. I need 4 hours out of the day because I used 4 different colors. So with 4 periods in the day, I can schedule all of these classes without any conflicts. I would need to schedule physics and German at the same time. Those are my purple vertices, so that means that those classes don't share any students, and so they're the same color, so they can be offered the same hour of the day. And then calculus, English, and discrete are all the same color. That means they don't share any students. They can all take place the same hour of the day. Collegiate reading, band, and psychology were all the same color. That means they don't share any students. They can all happen the same hour of the day. And then I would need a separate hour for PE. Now in a different coloring of this graph, I may have gotten that I could have PE the same hour as collegiate reading or band or calculus. In the particular coloring that we have, these are the classes that we got to be the same hour.